Imagine waking up one morning and the world feels wrong. Not because of an earthquake or a storm or anything you can see, but because time itself has started behaving differently. You swing your legs out of bed, but the floor seems to respond late, as if your feet are moving through honey. Your phone slips from your hand, but instead of crashing instantly, it floats downward in slow, graceful motion, like a feather falling through syrup. Even the air feels thick, heavy, resistant. Within minutes, chaos erupts around the world. Cars near the ground crawl as if someone hit a cosmic slow motion button. Pedestrians move in strange, lagging motions. Birds close to the earth flap their wings in eerie, drawn out cycles, unable to generate enough lift because the air around them feels like it's stuck in a different timeline. But look up just a few meters above the ground, and everything is normal. Birds cruising high in the sky, planes, clouds, even falling leaves snap back to regular speed as soon as they rise above this mysterious boundary. Scientists first think it's a glitch in our perception, then a gravitational anomaly. Then, something far stranger, time near the surface of Earth has slowed down, while the rest of the world continues at normal speed. Factories malfunction. Every machine designed with precise timing begins to break. Even your heartbeat struggles to adapt, beating sluggishly near the ground and normally when you stand up straight. The world is splitting into layers of time, and humanity is caught in the middle of a slow motion disaster. Please like this video, subscribe to the channel, and comment your question below. Time slowing down near the ground sounds like pure science fiction, but it's rooted in real physics. According to Einstein's theory of general relativity, gravity can slow time itself. The stronger the gravitational pull, the slower time passes. This effect is normally tiny on Earth, so tiny you'd never notice it. But in this hypothetical scenario, something has drastically amplified it. Imagine a world where the layer of air closest to Earth, say the first 2 or 3 meters, experiences time at half speed. Above that layer, time flows normally. This means every step you take, every breath you draw, and every movement your body makes would transition through two different timelines as you move through space. This is the foundation for our exploration. We're not changing gravity, we're changing time dilation itself, making it strong enough to affect daily life. Such a scenario opens up an entire spectrum of mind bending questions. How would biology react when your feet age slower than your head? What happens to machines that depend on timing? How does the planet handle a fractured time field? What does life look like when the environment itself has different speeds? In this video, we'll explore the physics, the biology, the environmental effects, and the long term consequences of a world where time bends dramatically just a few feet above the ground. Prepare to enter one of the strangest what ifs imaginable, where the Earth remains the same planet, but the laws of time itself do not. The first major consequence of time slowing down near the ground is that the human body becomes a battleground of mismatched biology. Your feet, legs, and lower torso would exist in slower time, while your chest, head, and brain continue in normal time every time you stand upright. This creates a bizarre physical split. The upper part of your body ages faster than the lower part, and your nervous system struggles to coordinate signals between two different temporal speeds. Consider this: nerves already transmit signals at high speed but still face tiny delays. If your legs were trapped in slowed time, those signals might arrive too early or too late relative to your brain's expectations. Walking would feel like controlling limbs through a lagging video feed. Every step becomes clumsy. Running becomes nearly impossible. Reflexes break down. Even catching a falling object would be tricky. Your arms move at normal speed, but your legs don't support the motion fast enough. This problem extends to the heart, which pumps blood throughout your body using a precise rhythm. If your chest beats at normal time, but your feet exist in slow time, blood flow becomes chaotic. Lower limbs might receive blood too slowly or too irregularly. You'd feel dizzy, unstable, and fatigued just trying to stand. Animals would experience this differently. Taller animals like horses or giraffes would be in constant danger. Their hearts, higher in normal time, would push blood into legs stuck in slower time, creating dangerous pressure imbalances. Smaller animals, especially insects, might adapt better because their entire body fits within one time layer. Machines fare even worse. Electrical circuits, engines, and robotics all rely on synchronized timing. An engine with lower parts and slowed time would misfire or tear itself apart. Conveyor belts, elevators, and manufacturing equipment cease functioning. Even simple tools like clocks or fans malfunction because different parts rotate or oscillate at mismatched speeds. Every technology we built assumes time flows uniformly everywhere. Break that rule, and the modern world collapses. The second major consequence of time slowing down near the ground is the environmental and planetary chain reaction that begins almost immediately. When the air close to Earth moves in slow time, The entire atmosphere becomes unstable because wind, temperature, and pressure rely on synchronized motion. Imagine a breeze trying to move across the ground. As soon as the air enters the slowed time layer, it decelerates dramatically. Wind patterns begin to tear apart. Turbulence increases near the surface as fast moving air from above slams into molasses like slow air below. This creates constant microstorms, chaotic vortices, and unpredictable gusts that whip into and out of normal time. Weather becomes unrecognizable. Rain falls into the slowed layer and begins descending in slow motion, piling up in suspended droplets. Storm clouds struggle to release precipitation. Water droplets may hover, distort, or merge in strange ways. Flooding becomes common because water movement is delayed, streams slow, rivers choke, and drainage systems fail as flowing water transitions between time states. Plants suffer next. The exchange of gases, CO2 intake, and oxygen release depends on airflow around leaves. With near ground air slowed, gas diffusion becomes inefficient. Photosynthesis plummets, crops grow sluggishly or die, forests turn yellow, then brown, then collapse. But the biggest shockwave hits Earth's climate engine, heat transfer. Warm air rising from the ground suddenly enters normal time, speeding up instantly, creating violent thermal updrafts. Cold air descending from above slows abruptly, causing temperature layers to fracture. Atmospheric convection, the very mechanism that drives weather, begins to fail. Animals experience immediate crisis. Birds flying low crash unexpectedly. Animals that rely on scent trails cannot track anything because scent molecules drift through slowed air differently. Predators miss prey. Prey can't escape. Entire ecosystems start unraveling. Anomaly. And then comes the oceans. Waves near shorelines slow in time, creating bizarre, frozen looking ripples. Tides become uneven. Sediment doesn't settle properly. Coastal currents misalign, disrupting global ocean circulation. Earth enters a state of temporal environmental collapse where every natural process is being stretched, delayed, or broken by the fractured flow of time. As days turn into weeks, the long term consequences of time slowing down near the ground reshape life on Earth in ways that are both extraordinary and devastating. First, human civilization relocates upward literally. Homes, businesses, and cities begin building raised platforms, suspended walkways, and elevated living spaces. Anything within the slowed time layer becomes unusable, so society abandons the ground like it's a toxic zone. People live on rooftops, bridges, and artificial platforms several meters high just to avoid the distortions. The ground becomes a strange, silent world where objects fall in slow arcs, where footsteps lag behind motion, and where sound moves oddly, stretched and warped. But not everything can be lifted. Roads, farms, factories, and most infrastructure remains stuck below. Agriculture collapses first. With plants unable to process gases normally and water moving sluggishly through soil, food production plummets. Humanity is forced to rely on vertical farming, hydroponics, and lab grown substitutes. Over months, another strange effect emerges: evolutionary pressure. Species that inhabit the slowed time layer begin adapting to it. Insects evolve thicker muscles to push through heavy air. Rodents develop unusual movement patterns that exploit the slower environment, giving them a bizarre advantage. New predator prey relationships form in this temporal twilight zone. Meanwhile, long term physics begins reshaping the planet. Erosion slows drastically, rivers carve land at half their normal pace. Geological processes near the surface lag behind deeper Earth time. The crust cools differently. Soil formation halts. The entire planet's surface becomes a mixture of fast and slow geological layers that no longer synchronize. Human aging also becomes a strategic matter. People who spend more time near the ground age slightly slower. Some attempt to exploit this, creating time therapy zones, but the biological stress of living in mismatched time speeds makes the idea too dangerous. Civilization survives, but only by abandoning the lower world and adapting to a future where the surface of Earth has become an alien landscape shaped by distorted time. In this hypothetical world, a simple but impossible shift, time slowing down near the ground, reshapes every aspect of the planet. What began as confusion and chaos quickly evolved into a full scale transformation of biology, technology, and the environment. Humans struggled first with the internal mismatch in their own bodies, hearts pumping across timelines, legs and arms responding out of sync, and reflexes breaking down under temporal distortion. Machines fared no better, tearing themselves apart as gears, wires, and circuits operated in mismatched speeds. Then the planet itself began to change. Weather unraveled as wind slammed into slow moving air, creating turbulence and fractured storm systems. Rain fell in suspended motion. Heat transfer failed. The foundations of climate collapsed. Rivers slowed, plants suffocated, and ecosystems spiraled toward extinction. Even the oceans, usually resilient, froze into layers of uneven motion. In the long term, civilization made a dramatic choice: evolve upward. Cities grew above the slowed layer. Transportation, energy, and food systems were reinvented. Humans survived only by learning to live in the thin band of normal time. But even with adaptation, Earth itself became a split temporal world, part normal, part sluggish, part alien. Life continued, but it continued changed forever. And if nothing else, this scenario reminds us of one thing: the laws of time aren't just abstract equations, they're the invisible structure holding life, climate, and civilization together. Bend them even a little, and the entire planet transforms. In the end, the question lingers: if time is the fabric of reality, what happens when that fabric starts to tear?